Okay, the decomposition reaction. We're just going to take a look at that real quick. The decomposition reaction. Bonds are always very stable and hard to break. We've got to add some heat or electricity in order to break them. That's just a hard and fast rule. Heat or electricity must be added. So you'll see that as a part of the decomposition reaction. The other thing you'll notice is that usually there's only one reactant. There are usually more than one product. So on the left-hand side, these reactants, you'll usually just see one. And then on the right-hand side over here, the product side, you will usually see more than one product as a result of this reaction. So looking right here at sodium chlorate, we're going to first add some heat, and then what you'll find is that you get sodium chloride. Sodium chloride is a very common and stable solid. That's just table salt. And what you'll get also is you notice, see, I've got the sodium, yeah, and I've got the chlorine here, yes, but I am missing the oxygen. So what do you think we get if we separate out all the oxygen? We'll get O2. That's a stable gas. You're breathing it right now. Okay? If you apply the same rules to zinc carbonate, what you're going to find is that, of course, you will get a little bit of zinc oxide. The oxygen and the zinc will combine to form a salt. A lot like NaCl, you get ZnO, right? Zinc oxide. And again, this is going to be a solid. And when you can see already we've got an oxygen accounted for and a zinc accounted for, but we're missing the carbon part. Well, if we want carbon to be split apart, here we're going to get CO2. Okay, again, very common gas. You're breathing it right now. If we apply the same rules here, we're just going to break this ionic bond between sodium and chlorine. What do you think we're going to get? Well, we'll get the sodium metal, which is a solid. We'll get that back. And we'll get chlorine back. But the elemental form of chlorine is actually a diatomic gas. It doesn't exist all by itself. It exists bonded to itself as a gas. Again, if you have a carbonate, here's the rule. The rule is that you'll get carbon dioxide out and an oxide of the metal that you've got. So what you'll have is you'll have barium oxide, and then you'll also create some CO2 gas. Okay? Barium oxide will be a solid. If you have aluminum bromide, well, you'll get aluminum, the solid metal, out. It'll actually be shiny. If you add some electricity, you'll get a nice shiny metal out of this. But you will also get bromide gas, which is a toxic gas and would have to be very carefully handled, or you could kill everybody in the room. All right, so radon and CO3, that's a carbonate again. So you're going to get CO2 as a result of breaking down a carbonate. You're going to get CO2. But you'll also get that radon out as a metal, so that'll be solid. Okay? This carbonate, again, or this chloride, I'm sorry, that's not a chloride, that's a chlorate. If you break down this chlorate, you will get oxygen. That's a rule, a hard and fast rule. But you can see if we take the oxygen out, we've still got calcium chloride left. So we're going to get some KCl. As a result, that's solid, and we'll get that with oxygen, okay? Chlorates always make oxygen when you heat them. Why would this be a bad thing? If you were in a laboratory and you were heating up calcium chlorate, you're adding heat and you're creating O2, why could that be a problem? Well, because of course oxygen is flammable. So if you have heat and you have O2, you could create an explosion. So obviously in class, we're not going to heat up any chlorates. It's just too dangerous. Okay, we'll talk more about this, but this is your primer to decomposition reactions.